Welcome, class. Today, we will be introducing the math behind the Bitcoin and blockchain. Bitcoin. This can be a pretty intimidating topic to jump into, but this video will break it down, that way anyone can understand it. We have the information organized into 3 parts. First, the Bitcoins, then the cryptography, then the math or elliptical curves. Throughout this video, we will also be indicating the level of difficulty of the topic we are covering by showcasing an animated woman in the corner of the video. This is easy, this is medium, and this means it's hard. Ready? Okay, let's get started. So what are Bitcoins? They're essentially a cryptocurrency, and just like any other sort of money, they can be used to purchase goods and services, except just online. And a great quality about the Bitcoin is that it can be completely virtual. There's no need for banks to store and track the money. So how exactly is the money taken into account if there's no bank? That's where the blockchain comes into effect. What we see is that it can record every Bitcoin transaction using ledgers, or a sort of digital file. Every transaction also has a bunch of information on it. It can account for all different Bitcoin transactions with everyone editing at the same time. Now, revisiting the idea about cryptocurrency. Essentially, it's a way of storing and transmitting data in a particular form, and this often uses private and public keys. And this is where the math, algorithms, computer science comes into play in order to make sure that the Bitcoin is safe.
If Alice creates a Bitcoin account, that account will be linked to 2 unique keys, a public key and a private key. Keys are mathematical information that can guarantee the transactions are valid. The private key takes messages and signs it so that other people will be able to verify the message with a public shared key. If Alice wants to send X Bitcoins to Bob, she will use her private key to generate a digital signature that will sign the message. Alice wants to send Bob X Bitcoins. When Alice sends this message to the network, everyone else in the network will be able to use Alice's public key to check if Alice's signature attached to the message is valid. If it is, everyone will add Alice's transaction to their blockchain. In other words, the public key is able to check if a transaction was signed by the private key. This works because of the ECDSA, a cryptographic algorithm that makes sure funds can only be sent by their owners. In addition, the Bitcoin network and your account will track your previous transactions to make sure that you have enough Bitcoins to spend. However, there can be network delays, so transaction requests will not be received in the same order. Therefore, to add a block of transactions to the blockchain, you have to solve a math problem created by a hash function, an algorithm that makes it hard to find the input when only given the output. Whoever solves the problem first will have their block of transactions added to the blockchain.
Let's proceed to discuss the basics of math behind Bitcoin.
So the first basic of math that we'll be talking about are lines. A line in geometry is composed of an infinite group of points. It extends to either direction infinitely. Let's examine some types of lines. First are vertical lines. A vertical line is a line with an undefined slope, running straight up and down, and can be written as x is equal to k. Second are tangent lines. A tangent line is a straight line that touches a function at only one point. Third are secant lines. Secant lines are lines that locally intersect 2 points on a curve. Now let's talk a little bit about some basic properties used in math that you probably learned when you're 7 or 8. The associative property applies to multiplication and addition. For instance, look at example 1. No matter how we group the numbers, it still yields the same outcome. The commutative property states that changing the order of addition or multiplication will not affect the answer. Something that is also similar to a property is an identity. An identity is an equation that is true no matter what values are chosen. For example, in this equation, it holds true no matter what value of a is used.
Now let's look at some operations on elliptic curves. Firstly, addition is the most fundamental operation. It's the basics of all the other operations, so we'll start with that. If given 2 points P and Q, P plus Q can be found by first drawing a line to connect these 2 points. The third point of intersection will be -r. Reflecting that point over the x-axis gives us r, where P plus Q equals r. P plus Q can also be derived algebraically by finding the slope of the 2 points. and using a couple of equations. Point doubling is when we add a point onto itself. Moving on to some subtraction. So, if given the equation p minus q, we can rewrite that to be p plus negative q. And now we've turned our equation to simple addition. Negative q is q reflected over the x-axis. Going on to multiplication, also known as scalar multiplication, is built off of addition. Let's take an example where n times p will equal to p plus p plus p n number of times. There are a myriad of different ways to solve multiplication. The simplest way is double and add algorithm, which is what we will be looking at. Let's further our example by letting n equal 200. Our first step will be turning this number n into a binary number. So our example will be 11001000. We can turn this into an equation with the powers of 2. So the last digit of our binary number correlates with the first coefficient of 2 to the power of 0. Similarly, the fourth digit of our binary number correlates with the coefficient of 2 to the power of 3. Look carefully to see how each digit of our binary number correlates with the coefficient of one of the terms. So we can rewrite this as being 2 to the power 7 plus 2 to the power 6 plus 2 to the power of 3. Remember how we're multiplying this by point p, so each one of our terms is also multiplied by p. How exactly do we solve one of these terms? Well, this is where the doubling comes in. Because 2 doubled equals 2 to the power of 2. Doubling that gives us 2 to the power of 3. Continuing on this way, we can get 2 to the power of 7 and all of our other terms. Adding it will give us the multiplication. So moving on to division. This is the last operation. So p divided by q can be rewritten as p times q to the power of negative 1. We can find q to the power of negative 1 by using the Euclidean algorithm, also using some modular arithmetics. As you see here on the screen, we have an equation using modular arithmetics, where the residue of y will equal q to the power of negative 1, or the inverse of q. To recap all of this, we see that operations aren't so hard after all. In fact, most of these operations are simply built off of one another, all tracing back to the simple addition.
Moving on from the basics of math, let's expand our view and discuss the finite field. The finite field is a field or plane composed of a finite number of elements, unlike the Euclidean plane. Usually in this field, basic rules of addition, subtraction, multiplication, and division apply. Below is an image showing how polynomials get broken up. Now let's move on to one of the more interesting parts, the point at infinity. So the point at infinity is a concept that is interesting in the way that is hard to grasp at first sight. I know for sure that I didn't grasp it at first sight or second or even third. The point at infinity, or the ideal point, is an idealized limiting point at the end of each line. In the case of an affine plane, for example the Euclidean plane, the point at infinity is where each of the pencils of parallel lines in a plane are connected. As shown here, the point at infinity completes the line into a closed curve. As of now, you may be staring at your computer wondering what is this random assortment of numbers and letters. SECP25K1 is the parameter of the elliptic curve used in bitcoins. The basic formula for an elliptic curve is y squared is equal to x cubed plus ax plus b, but in Bitcoin, the equation for the curve is just y squared is equal to x cubed plus 7. SECP256K1 is a unique elliptic curve. Most commonly used curves have a random structure, but this was constructed specifically to make sure that there is no randomization or unpredictability. This ensures that there is no way that the creator could say "Bobby" and dish on the investors. Now, figure 3 is not as random as you might think. The meme is called a dead boy, and it was generated from an individual that was commenting on Bitcoin. In the end, what we can take from this is that Bitcoin can impact your life, not just to make you rich, but also to give you some laughs.
Thanks for watching. We hope you enjoyed our video.